Hello everyone, and welcome back to our inventory system series in Godot 4. In the previous parts, we created our hotbar, and we can now assign, unassign, and use our hotbar items using our keyboard shortcuts. Now in this part, I want us to alter our inventory a bit so that we can reorganize our items by dragging and dropping them. If we click on an item using the left mouse button, the usage panel should show, allowing us to use, drop, or assign an item. But if we click and hold on an item using the right mouse button, we should be allowed to drag the item to an open or taken slot. If we place an item on an open slot, it should automatically just reassign the item to that open slot. But if we place an item on a taken slot, the item should swap places with the pre-existing item on that slot. So let's open up our project and we'll first head to our inventory slot scene. Now, because we want our item button to execute two separate events for two different inputs, aka our right mouse button and our left mouse button, we'll have to disconnect its on-press signal from our script. Remember, we want to do this because we want our right mouse button to drag the item and our left mouse button to interact with the item. To be able to do this, we'll have to use a GUI input event from our control node instead. The GUI input signal is a specialized event handler for GUI elements in Godot. We use it to respond to user interactions in a context-sensitive way, which we'll need right now to implement our features such as drag and drop. So, attach your item button's GUI event signal to your script. In this newly created function, we will first need to check if the input is a mouse input, since we only want to execute mouse events for our inventory slot. Now, if the event is a mouse event and the input is our left mouse button, we will execute the functionality that we previously executed in our onPress signal function. You can go ahead and delete your entire onPress function since it's not connected, it won't execute, and we also don't need it anymore. If we press and drag our right mouse button whilst focusing on a slot, we want to notify our game that we are dragging an item. If we release the button, we want to notify the game that we have stopped dragging the item. We also want to change the color of the outer border to a different color to indicate that we are dragging or releasing the slot item. This part is just for visual effects so that we can see that we're actually dragging the item. So at the top of your script, let's create an onReady variable reference to our outer border. We'll also have to create two new signals. The first one will notify our game that we are dragging a slot, and it should contain the slot that we are dragging as a parameter. The second one will notify the game that we have finished dragging our slots. Now back in our GUI input function, if the right mouse button is being pressed, we will emit our drag start signal and change the outer border color to indicate that we are dragging the item. If the button is released, we will emit our drag end signal and reset our border color to show that we are no longer dragging the item. If you run your scene, your border should show green if you right-click on it, but if you left-click on it, the usage panel should still show. The rest of the functionality we will have to do in our inventory UI script. So open it up, and at the top of your script, we'll need to create a new variable that will store the slot item that we are currently trying to drag and drop. We'll have to create two new connector functions that will connect to our signals that we just created in our inventory slot script. These functions will allow us to execute drag and drop events for each slot in our grid container. We'll start with the connector function for our onDrag start signal. When we start dragging our slot, we'll simply assign our dragged slot variable to a reference of the slot component. Our function will pass the slot as a control node parameter, since we want to reference the entire slot component, which we know has a control node as its root node. We'll also need to create a connector function for our drag end signal. When we stop dragging our item, it means that we want to drop our item in a new slot. We'll need to get the slot that we are trying to drop our item on, aka our drop target, and either drop it into an empty slot or swap it with a taken slot. Either way, we will swap the drag slot with the drop target slot. We'll need to create a few more functions for this to work, so for now, let's just create the skeleton of our drag end connector function. Now, whenever we populate our grid with slots or update our inventory UI, we'll connect each slot signal to these connector functions. This will allow us to execute drag and drop events for each individual slot within our container. Okay, so previously I said we'll need to do two things to finish off our onDragEnd function. The first thing is to determine our drop target, aka the location where we want to drop the selected or dragged slot in our grid container. To determine this drop target, we'll need to find out where exactly our mouse is located on our grid. And then based on this position, we'll need to see if it is within a slot. So if our mouse is within a slot in our grid container, we will return the position of that slot since that slot is our new drop target. If our mouse is not within a slot, then it means that we are trying to drop it at an invalid position, like outside of the border or outside of the grid. So we'll just return null since it's invalid. In our onDragEnd connector function, we can now create a new variable that will store this returned position of our drop target. Okay, so we have our drop target and its position. Now, the second part of the function is where we actually want to place our slot item in the drop target. We'll need to create a new function that will assign an index to each of our slots within our grid container so that we can get the data and position of each individual slot. We will return the slot if it is found, and we will return -1 if we have reached the end of our array, meaning no remaining slots have been found. With our slot index created, we need to create a new function that will drop the item at that index. This function will take two slots as its parameters. The first slot is the slot that we are dragging, and the second slot is the slot that we are trying to drop our item onto. We'll start by calculating or getting the index of the two different slots in the grid. If either of these slots are invalid, meaning they don't exist, we'll need to error handle, aka print that the grid container does not have that slot, and then just return on our function. If the slots are valid, we'll need to swap the item. For this, we'll need to create a new function in our global script, which will swap our inventory items based on their index. In this case, the parameters of index 1 and index 2 will check whether or not our slot 1 and slot 2 index parameters in our drop slot function are within the bounds of the inventory array. If either index is less than 0 or greater than or equal to the size of the inventory, the function will return false, meaning they shouldn't be added to the inventory. If both the indexes passed into the functions are valid, then we will swap the items at index 1 and index 2. We'll store the item that we want to drop in a temporary variable while the swap is being performed. After the swap is complete, we will emit our signal and update our inventory to reflect these new changes. We'll also return true to tell the game that we have successfully swapped our items at the two slots. Now back in our inventory UI's drop slot function, we will check if the indexes of our slot 1 and slot 2 parameters are valid by calling our newly created global function. If they are valid, we will refresh the inventory UI so that we can reflect the changes in the inventory data. Okay, so I know that was a lot, but we can go back to the to-do in our onDragEnd connector function and call our drop slot function. We will pass the drag slot as slot index 1 and the drop target slot as index 2 so that we can say that these are the indexes that we want to check. Okay, so with all this heavy work out of the way, we can now run our scene to test if this works. You should now be able to right-click and drag on a slot item, and wherever you drop it, it should be able to reassign to a new slot on drop. And that is it for now. We will break it off here, and in the next part, we will make our hotbar inventory draggable and droppable. That's it for me. Thanks for watching, and I hope to see you in the next one.